Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X researcher and professional physicist, and today I'd like to talk to you about another one of my articles. This one is entitled Health Effects of Geomagnetic Storms. And geomagnetic storms are the result of solar activity such as solar flares, CMEs, or coronal mass ejections and coronal hole streams. And these impact the Earth's magnetosphere and heavily ionize our ionosphere. And this heavy ionization leads to induced currents on the surface of the Earth and inside the Earth, which can lead to communication as well as power disruptions and increased earthquake and volcanic activity. In addition, they also have negative health effects on the human body. And first of all, solar activities are usually associated with the release of cosmic rays or relativistic ionized particles and energetic radiation in the form of X-rays and gamma rays. And in the past, the Earth's atmosphere has done a good job of protecting living organisms on the surface of the Earth from this radiation. The Earth's atmosphere absorbs most of the high energy radiation impacting our planet. Gamma rays and X-rays are well absorbed by the atmosphere. And most high energy particles from the solar wind are effectively blocked from reaching the surface as they are deflected by the Earth's atmosphere and magnetosphere. Some high energy particles like protons and electrons spiral along the Earth's magnetic field lines and are reflected back and forth by the Earth's magnetic poles. And these particles become trapped in what's called the Van Allen belts. And we can see what the Van Allen belts look like. The inner one is where protons become trapped, and the outer one is where electrons become trapped. And so most high energy particles are effectively blocked, and however, the strong magnetic field at the Earth's north and south pole then act as mirrors, reflecting these electrons and protons. But some of these particles always manage to get through the magnetosphere, and since the number of particles impacting has been increasing, it is inevitable that some will reach the surface and cause some damage to living tissue. The atmosphere, however, has never been able to protect us from cosmic rays. And cosmic rays are particles with an energy of greater than 100 MeV. And these particles go right through the magnetosphere as if it was not even there. And they travel at very fast speeds, say 40% of the speed of light. So they are relativistic. And cosmic rays are mostly ionized hydrogen, or in other words protons. That is 89% is protons. There is some ionized helium, about 10%, and that leaves 1%, which are other nuclei such as iron, silicon, oxygen, carbon, and magnesium. Now, when a cosmic ray, such a high energy proton, impacts the atmosphere, it collides with an atmospheric particle, which is mainly nitrogen and oxygen, and it causes what's called an air shower. An air shower is the production of a cascade of secondary particles and gamma radiation. Some of these particles produced are the pions, symbolized by the pi, as you can see here. Here's the proton. It impacts an atmospheric particle, and we see pions being produced first. This is a positive pion, a negative pion, and a neutral pion. There are three types of pions, and these have a very short half-life. That is, they don't live for very long, and they decay into other particles such as gamma rays and muons. And we see the muons here. They are positive muons and negative muons. This is an antineutrino, which does not do any damage. It goes through most matter and living organisms. And but the gamma rays give rise to particle-antiparticle creation. We see gamma rays here. This is a gamma ray, that's a gamma ray. And they lead to electron, positron. The positron is an anti-electron creation. They can also lead to proton and antiproton creation. So an air shower or cascade of particles is seen here. The protons are not very damaging because they quickly absorb an electron and become hydrogen, but the neutrons are problematic. And I'll explain this lower down. So muons are stable enough to reach the Earth's surface, and they do cause damage to living organisms, and they can result in mutations, and that may lead to cancer. And cosmic rays also deplete the ozone layer and so increase the UVB radiation emitted by the sun reaching the Earth's surface. This is the more energetic ultraviolet radiation, which is also cancer causing. The UVA is the lower energy ultraviolet radiation, and our atmosphere usually allows this ultraviolet radiation through, and it's not as damaging, but overexposure prematurely ages the skin and suppresses immunity, which may in turn lead to susceptibility to bacterial and viral infections. Now, the other cosmic ray particle I've mentioned is the neutron, that is extremely damaging. It doesn't react with matter as well as the proton because it's neutral. It's also very heavy. So it's actually more damaging than gamma rays. But when a nucleus absorbs a neutron, what's given off is usually a gamma ray, which can then ionize other particles. So the neutron is cancer causing and more damaging than even gamma rays. So the usual source of cosmic rays is from outside the solar system, and the sun's solar wind produces a bubble around the solar system which deflects most of these particles. However, when the sun weakens, as it has been doing for a few years, the cosmic ray flux impacting the Earth increases. And since the sun has been becoming weaker and weaker as a result of the objects in the inner solar system affecting it, the cosmic rays impacting the Earth has been increasing. However, as the sun's activity increases, as we see it has been happening lately, the sun has also become a very good source of cosmic rays. In addition, the corona stops very high energy particles from leaving the sun's surface, but we have increasing numbers of coronal holes on the sun, and the sizes seem to have increased, or they do so periodically, and these lead to high energy particles being able to leave the sun, and these are basically cosmic rays. These cosmic rays are detrimental to human health, and the most likely initial effect is tiredness and inflammation as the body tries to deal with assault on its cells. Inflammation usually leads to pain. And what we see here is a representation of the brain. These are brain cells or neurons that connect to each other and forming a huge electrical circuit. And the fact that there is ionization in the ionosphere due to geomagnetic storms, this of course causes induced currents in the Earth and also in the human body, which is basically an electrical system. And these electrical currents will affect this electrical equilibrium and will affect the whole body, but especially the brain. And they also cause magnetic fields because induced currents lead to induced magnetic fields. And magnetic fields have been known to impact the human brain in several ways. These fields affect the brain's ability to release serotonin in synapses, and synapses are the connections between neurons or neural cells in the brain. And a decrease in serotonin is associated with depression, anger, anxiety, insomnia, and headaches, including migraines. Radio waves can also affect the transfer of serotonin across synapses and can lead to the same problems. In addition, there is evidence that geomagnetic storms can affect mood and therefore behavior and cause heart problems and even affect the stomach lining. A common consequence is circadian rhythm disruption, which may manifest as a person waking up, say at 2 a.m. and not being able to go back to sleep. The brain is a complex electrical circuit which will of course be easily disrupted by induced currents, which may result in a person feeling anxious, nervous, jittery, and irritable, and having short-term memory loss. Increased induced currents in heart tissue may lead to heart palpitations. Increased stress due to the effects on the brain may of course also lead to digestive system problems, which may result in nausea and queasiness. And strange feelings such as head pressure may also occur, and as well as headaches are possible. And if people have injuries, these may lead to increased pain because the induced currents affect nerve impulses. So in conclusion, the increased solar activity and resulting common occurrence of geomagnetic storms is very likely to be having multiple negative effects on the human body, from suppression of the immune system to cancer, and also to headaches and anxiety due to serotonin deficiency. Other health effects involve circadian rhythm disruption, nerve impulses, the heart, and even the digestive system. This is Dr. Claudia Albers, Planet X Physicist. Thank you for watching.